Okay, so hopefully you've had a chance to look at the video that I left you that was going to introduce the idea of Newton's first law of motion. So first of all, Newton is a famous scientist that is known for three different laws that we're going to learn about. And we're going to learn about each one individually and look at some examples that help support or give you a better idea of remembering what those laws are about. So the video you guys watched gave you some different examples of Newton's law and tried to explain it. Now I'm going to give you guys a short note on just basically what it is and a few more examples to go along with it, and then another short video. So Newton's first law of motion is also known as the law of inertia. So this word inertia will help you to understand Newton's first law. Inertia basically is just the ability of any object to resist a change in motion. So this is key here. It resists a change in motion. So it can either be an object that's not moving and it wants to stay not moving, so it's resisting changing what it's doing. So if it's at rest and it's just sitting there, it wants to stay there. But if it's already moving, it wants to continue doing that. That's what the law of inertia is. And that basically sums up Newton's first law of motion. And if you think of the different examples that they gave you in that video, if you set a ball in motion, it would like to continue moving unless something acts on it to stop it, right? So if we were to set a ball rolling on the ground, it's going to continue until something stops it. And usually it's a wall or it's friction with the ground. If those things weren't there, let's say we were up in outer space, and you set a ball in motion, there's very little to no friction and anything to stop it. It's going to continue on in that path that you set it in until something stops it. So inertia just means it wants to continue doing what it's already doing. So if it's at rest, it likes to stay at rest. If it's moving, it likes to stay moving. And that's what it means by resisting change in motion. I have a couple photos here that are going to help sort of explain that as well. So inertia, remember, if something's moving, it wants to continue moving. So inertia, your truck has brakes. This massive hunk of stone doesn't. So this truck was initially moving, and the truck has brakes to slow the truck down. But because this massive stone was moving at the velocity of the truck and it doesn't have its own set of brakes, it wants to continue moving. So there's an example of Newton's first law and why you would want to secure this massive hunk of stone down if you were driving this truck. And another example, inertia, to stay in motion until acted on by an external force. Remember I said if you're already moving, you want to continue moving unless something acts on you to make you stop. So unfortunately, this guy, his bike got stopped by the tires, but he wanted to continue moving. So that sort of sums up what the word inertia means. And it also sort of sums up what Newton's first law is. And that's because Newton's first law is sometimes called the law of inertia because it follows those rules. Okay, so we're going to sum up here. There's three main points to kind of remember for Newton's first law. And I just basically went through them with you. So an object at rest will stay at rest unless acted on by an external force. So if it's already at rest, it wants to stay there. Unless you push it, you apply some sort of force to it. And the opposite, an object in motion wants to stay in motion unless it's acted on by an external force to try and stop it. So remember, any object wants to do what it's already doing, unless there's a force to make it go or to make it stop. And this one here I'm going to underline because this one's really important that people often forget. Remember we just finished talking about the net force of different objects? So if we have different forces acting on an object, we can figure out what the net force is by adding up all of the different forces and figuring out what the net overall force is on an object. This is key to Newton's first law. If the net force is 0, then it can mean two things. A lot of people think it just means that the object has to be at rest, but it can actually mean two things. And the first thing is that the object is at rest. That's one sort of obvious. If all of our forces on an object are balanced, then it's probably not going to move. But the one extra thing that people don't think about is that if our net force is balanced, An object can also be moving with a constant velocity. Okay, and this is going to start to make a little more sense when we deal with another one of his laws. But just for now, remember that if you see an object and its net force is 0, it can mean one of these two things. One, that it's at rest, or two, that it's moving with a constant velocity. It can be either of those two. So that's key. A lot of people just think that it must be at rest, but it can also be moving with a constant velocity. Okay, so if we think about our free body diagrams that we just drew, remember I said that how long our line is, our vector force line, tells us a little bit about the amount of force that's acting on it. So if this line is the exact same length as this line, it usually means they're balanced out. So we try to draw our free body diagrams so that if they're equal on both sides, the lengths of those lines should be equal. So this could be something like, let's say this is 12 newtons to the left. If this line is the same, we can assume pretty much that this is also 12 newtons to the right. Okay, and let's say this was 500 newtons up. These are balanced, so you can probably say it's 500 newtons down. So this is an example of where our net force is equal to 0 newtons in the up and down direction and in the side to side direction. So this object, we don't know, but this object could be at rest, or it could be moving along with a constant velocity. And the constant velocity thing might be a little hard to wrap your head around at this point, but you'll see in the next law why that makes sense. So it could also be moving with constant velocity. Now an example of where it's not, let's say this were 40 newtons to the right. See how much, it's much longer than this side, and we can keep this at 12 newtons. And let's say, look, these guys look balanced, so we'll stick with the 500 up and the 500 down. Our net force in the vertical direction is 0, but we have a net force horizontally of positive 40, right, in the positive direction, plus negative 12, or minus 12 is the same thing. And we end up with a net force of positive 28 newtons to the right. So as soon as you see that any of your forces are unbalanced, meaning that one of your vector lines is longer on one side, that means that it's moving with a certain acceleration, so it's not constant velocity anymore, and it's not at rest, because this unbalanced force is going to force it in that direction. Okay, so this is just key to remember for Newton's first law. When all your forces are balanced, you can assume it's either not moving at all or it's moving with a constant velocity. When it's unbalanced, what we end up having is something is accelerating, it's speeding up. So that's going to lead us into Newton's second law. But I have another video I want you guys to watch, and then I have some questions to sort of just get you thinking about Newton's first law today.